Right. Good morning. So today we are going to start a new unit. So we have finished unit number 4 in programming. Right. I took enough time in programming because the programming is also in grade 9. So I have explained some of the programs included even in grade 9. Right. So we spend more time in studying about programming, right? So this is unit number 5. In your book, it is given, the title is given for unit number 5 is physical computing, I think, but it may be any related name. There may be different names given. So I take this unit as logic gates. Okay, logic gates. This is the title for this unit number 5. But in your book, there is another name given. So doesn't matter, names are not a problem. So you can take this as a logic gate. Right. First of all, you should understand the term, because this is a term that you never ever heard before, because it's a new term. It may be related to a particular field. That's why you know about gate, right? Your house has gate, your school has gate. So gate is something related to an entry point. To come to your home, we use the gate, right? Gate is the main way to enter your home. So that's why it is gate. So here also you have this name gate. It may be because of the similar reason, right? But actually it is related to electronics. So this unit is related to physics or electronics. So that's why you didn't have any experiences with this word previously. Okay, nobody, I'm sure nobody studied this one earlier, or nobody had heard about it. It's a new term. Okay, right. So logic gates or logic is something related to physics, and also it's very advanced thing. So you can study a lot of things about logic gate, but for someone who is studying in grade 8, we cannot teach all these things. So only some basics about logic gates are in your syllabus. So this may be the very first time that you start learning about logic gate, but you will be learning about logic gates in the next grades, right? Grade maybe 10, not in 9, grade 10 maybe right thereafter. So it is there. Okay, first of all, I should explain what the logic gate is. Okay, listen to me. It takes some time to understand the concept. Maybe at the beginning it may be little difficult to understand, but wait patiently. It will be very simple when we go through. Okay, so first of all, logic gates or logic gate is an electronic circuit. Okay, remember that point first. It is an electronic circuit. Okay, that is the first point to be remembered. It's an electronic circuit. So since it is an electronic circuit, it works on electricity, right? So it's a circuit, which means there are so many electrical components included. It works based on the electricity. So you have to supply the electricity in order to perform it, right? So the second point is it works on electricity, right? That is very important. It functions on electricity. Right, look, I tell you the function of the basic function of a logic gate. So generally, logic gate, as I told you earlier, logic gate is an electronic circuit, right? So what this logic gate does is it takes the electricity, right, through wire. It takes the electricity through wire, and this logic gate will perform some special functions. Later we will discuss, right? This logic gate can perform some unique functions, special functions. As a result of that function, this logic gate will provide output. So electricity is taken, we call it as input, and then within that logic gate, something happens, some processes are going on. As a result of the processes, you will be able to get some output. That may be electricity, sometime that may not be electricity. It would be better if I explain them in a very simple diagram, right? That may give some idea. Have a look at this. I will explain this. Look here. Right, look here. So assume this is the logic. This is the logic gate, right? I just put a rectangular square because I just want to show the basic idea about the logic gate, not the proper figure or proper symbol, right? Just put a rectangle in order to show the idea. So that's why this kind of a diagram is called block diagram. So block diagram is the diagram to describe some features or some functions, but that is not the real logic gate. Later we will discuss about the real logic gate, right? So assume this is logic gate, okay? This is logic gate. Simply, it's a physical part, right? Physical component. So now, how did I explain? Logic gates consume electricity, right? They need electricity. So assume I have taken two wires, okay? Two wires have been taken. This is the first wire. Let me take it as A. This is the second wire, B, right? So we have two wires, wire A and wire B. And see, this wire can have the electricity, or this wire also has electricity. Now, what happens? Inside of this logic gate, something happens. Some specific functions will be taken place. We don't know what they are because we are introducing the gate. Later we can discuss in detail. So now for the moment, assume something is going on, right? Because this is the logic gate. It has some electronic components inside, like diodes. You might have heard, right? A diode is there, a resistor maybe there, right? In science, you might have studied these things. So some electronic or electric parts inside. As a result of them, you will be able to get an output. These two are inputs. I call them as wires. Yes, they are wires, but they are called inputs because they are used for taking the electricity to the logic gate. Okay, these two wires are used for input the electricity to the logic gates. That's why they are inputs. I have two inputs here, but look at this. This is not an input because this is not used for inputting the electricity to the gate. This is the opposite. See, this is used for taking the electricity from the logic gate. So this can be called output. I can name that as X or something, right? So in this diagram, X is the output. So this is the basic diagram or block diagram for describing the function of logic gate. So we provide the electricity through inputs. Something will happen inside. We don't know what it is because we have to discuss later about there are a number of logic gates available. So when I explain or when I introduce those logic gates, I can explain the function. But for the moment, we assume that some functions are going on. As a result of that, you will be able to get the output. But note, output can be only one, right? There is always one output taken by the logic gate. You cannot have two outputs, only one output. But when it comes to inputs, there can be any number of inputs. Sometimes one input, maybe two inputs, three inputs, four inputs possible. but we will be working with 2 inputs only, because as I told you earlier, we have only the introduction part. So if you have 3 inputs, 4 inputs, you know, the logic gate becomes complex. That's why we have only 2 inputs. Okay, but there is always one output. This is logic gate, but here I have put a rectangle because it is only for showing the idea. Okay, right. Listen to me, I have to explain some other things. So up to now, you should get some idea. So up to now, I explained about these things. Let me recall again. First of all, logic gate is an electronic circuit. Okay, so since it is an electronic circuit, it needs electricity as inputs. And after performing a unique function, the logic gate will provide the output. Okay, here output means that may be electricity or may not be electricity. That is possible because look here, even you have 2 wires as inputs. So with 2 wires, sometime we can supply the electricity, sometime we don't. So assume wire A has electricity, but I can stop the electricity in wire B. That is possible, right? Wire A has the electricity, but wire B doesn't have electricity. In this case, there will be some functions carried out. As a result of that, we have an output. That may be electricity, that may not be electricity. Actually, it depends on the logic gate, right? Output depends on the logic gate, not only on logic gate, maybe on inputs too. So as I told you earlier, sometimes both inputs have electricity. There, at that particular instant, there will be an output. Sometimes first, which means input A has electricity, but input B doesn't, right? So in this case, you can't say that the same output will be taken because now you have different inputs. So what I'm trying to tell you is the output of a gate, of a logic gate, depends on 2 factors. First one may be this one, the logic gate. Because as I told you earlier, we have number of logic gates, not one, right? There are number of logic gates. So it depends, that output depends on the logic gate. Not only on logic gate, it depends on the inputs too, because not all the inputs have electricity all the time. Sometimes they have, sometimes they don't have. So it also depends the output. It also decides the output. Okay, right. Next point, look, listen. When an input has electricity, it can be taken, right? Assume that input A has electricity, right? So when an input has electricity, it can be taken as 1, okay? If it is 1, it means there is an electricity in the wire. If a wire doesn't have electricity, it can be taken as 0, okay? No electricity is equal to 0. This is very, very important for the rest of the lessons, okay? If an electricity, if a wire has electricity, which is 1, right? If a wire doesn't have electricity, it is 0. So these meanings can be very, very much important in the rest of the questions. And also one more thing, if a wire has electricity, sometimes it is called high, right? If a wire has electricity, I will raise this. If a wire has electricity, that can be taken as 1, right? At the same time, that can be taken as high. Okay. So if an input is in high state, which means that has electricity. So having electricity, high, 1, same, right? The meaning of these 3 things are same. There may be some other words too, but remember these 3 because for grade 8, these are important. Okay, electricity, that can be taken as 1, and also it can be called high. Similarly, If a wire doesn't have electricity, I told you that it is 0. At the same time, that can be taken as low. Low, right? Low means no electricity. High means there is an electricity. Okay, right. So now I know some of you may have understood the concept. Some of you may not have, right? Doesn't matter whether you understood or not. We will be working with logic gates after writing these introductions. There you can get some idea. So maybe since it's a new subject, it may be a little difficult to get some idea at the beginning, but wait patiently. It will become very simple if we go through, or once we go through, right? Okay, so better we can write these things first. After that, I will explain the logic gates used in electronic devices. Even in computer, you know, computer is full of logic gates. Inside of your computer, you have hardware, right? Motherboard, and there on the motherboard, there are so many circuits are there. There we have logic gates. So that's the reason why we are learning about logic gates in ICT. Not only computer, most of the electronic devices use logic gates in order to function or in order to perform the operations. Okay, right. Now put the heading. Right, logic gates, unit number 5. Write the heading. For unit number 4, we don't need to write anything because that is programming. There we have to draw the symbol and everything. So that's why I told you not to write it. I will give a printout. So this is unit number 5, logic gates heading. Logic gates. Logic gates. Okay. So now write the first point. Write as points. First point. Logic gate. Logic gate. Logic gate is an electronic circuit. Logic gate is an electronic circuit. Is an electronic circuit which consumes, 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 right? Which consumes. So consume means which take, right? Which takes, which consumes the electricity, which consumes the electricity, which consumes the electricity as inputs, as inputs, as inputs, and produces, produces, produces an output, produces an output after performing a specific function, after performing a specific function. Okay, so the definition seems to be little bit big, but it's not a big thing. If you understand the summary of the logic gate, you can, right? So what did I tell? Logic gate is an electronic circuit which takes electricity as inputs, and after performing a function, because inside of a logic gate something happens, some functions will be taken place. So after performing a particular function, it produces the output. That's a very simple idea, right? Next point, second point. Second point. Inputs and output, inputs and output of a logic gate, I repeat it, inputs and the output of the logic gates may or may not have electricity, have electricity.
So guys, tell again, I have net problem.
Okay, I repeat that sentence. Inputs and the output of a logic gate may or may not, right? May or may not have electricity, Okay, next point, third point. The output of a logic gate, the output of a logic gate depends, D-E-P-E-N-D-S, depends on two factors, TWO, two factors, right? In the next line, number one, right? Number one, nature of inputs, Number two, types of logic gates. Okay, it depends. That output depends on two factors. First one, the nature of inputs. Nature of inputs means the state of the input, whether it is 0 or 1, right? That's the nature. So, because as I told you earlier, not all the time, all the inputs have electricity. Sometimes they have, sometimes they not have. So, depends on that state of the input, output will be decided, right? That's the meaning of nature. Types of logic gates means, as I told you earlier, this is only a block diagram. This is not the exact logic gate. So we have some gates in electronics. So every gate decides a different output. Okay, because they have different functions. So based on the function, you will be getting different results. Okay, right. So maybe in the next line, I'll put a subtitle, block diagram for logic gate. A subtitle, right? Subheading, block, B-L-O-C-K, block diagram of logic gate, Okay, now draw this diagram. A, B, these are inputs. This is output. I put it as X, right? that shape is logic gate, right? This rectangle shape or that square shape is called logic gate. Finish it, draw it first. Don't forget to label them. This is A, this is B. Show them as inputs. This is the logic gate, right? This one single wire is output. Take that output as X or Y or anything, right? You can put any letter there. Even for inputs also, you can have any name, right? It may be XY or PQ or AB or whatever. Finished?
Yes, sir. Finish it.
What about the others? Finished or not? Is there anyone who doesn't finish yet? Anybody who is not finished yet? Okay, all of you finished, right? Right. Again, I tell you not to worry about this one diagram. Even if you don't understand now, it's not an issue, because hereafter we will be working with logic gate. There we will be using the real gate, right? So there we can get some more knowledge. So even though it may not be clear now, it's not an issue. But if you understood the points which I mentioned, then it's fine, right? That may be easy to go forward. But even if you don't understand 100%, it's not an issue. Okay, wait, we will be taking some other things, and there it will be very simple. Okay, right. So now, right, look. So now, as I told you earlier, we have different logic gates, because inside of the computer, we need to perform different functions, right? With the electricity, we have to perform different functions. So we need number of logic gates. There may be many logic gates, but for us, only 3 logic gates are expected. So in our syllabus, only 3 logic gates are included. But in electronics, there are logic gates which are more than 3, right? We have number of logic gates. So basically, all the logic gates are divided into 2 categories. Okay, logic gates used in electronic devices can be divided into 2 types. The first type is called basic logic gates. Basic logic gates. The second one is called combination of logic gates. So even you can call combined gates. Combined gates. Okay. All the logic gates are divided into 2 categories. The first one, basic logic gates. Second one, combination of logic gates or combined logic gates. Okay. Basic logic gates, combined logic gates. I can put the word logic. Right, look. In basic logic gates, or in this particular category, we have 3 logic gates. Look, every logic gate has a unique name, right? Every logic gate has a unique name. That name is given to that gate in order to in order to reflect the meaning of the or the function of the logic gate. I repeat it, every logic gate has a name. That name is not a random name or not a meaningless name. That name is given for that particular logic gate based on the function of that gate, right? So we have three basic gates. The first one is called AND logic gate. Capital letters are AND. So as I told you earlier, this name has the meaning. So when you study about AND gate and its behavior and its function, then you could easily understand why it is named as AND. So there is a connection between the name and the function of this gate. I will be explaining these things later. Then there is another gate called OR gate. Again, capital letters, OR gate. So this is another logic gate, but definitely the function of the logic gate OR will be different than the function of AND gate. Both are logic gates, which means both are electronic circuits, but both must have different functions. Okay, we can introduce those functions later. Then there is another one called NOT gate, capital N-O-T, NOT gate. This is another logic gate with another function. Okay, right. There may be some one more gate can be applied or can be included as basic, but slightly advanced. So I skip that. For us, three basic logic gates: AND gate, OR gate, NOT gate. Okay, right. These are called basic. I tell you the reason why these are called basic little later. After introducing this combination of gates, I tell you the reason why these are called basic and why these are called combined, right? So we have two combined gates. There may be more than two, but again, I tell you for us or for a beginner, they are two, right? We can take them as two. So two combined gates are there. They are also electronic circuits, but they are called combined gates. The first one is called NAND gate. NAND gate. You can clearly see a letter N in front of AND, right? You have AND here. See, there is also AND, but in front of A, you have N. So there may be connection between this one and this one. Later, I can explain, right? So we have another one called NOR gate. NOR gate. This is another logic gate with another function. So here also you can see the pattern. N, there is a letter N in front of the word O. So he's here, right? So it may have, these two may have relationships or connections. I will explain. Okay, I will explain. So these three gates are called basic logic gates, and these two are called combined gates. First of all, before introducing these gates, I tell you the reasons why these two gates are called combined and these two gates are called basic. Look, these two gates are built by combining two basic gates. I repeat it, NAND gate and NOR gate, they are manufactured or they are built by combining two basic gates. Look here, look at this name, okay, closely. NAND. So N means not, right? N, the letter N denotes not. And obviously you have AND. So what are the two gates mixed there?
Not an AND.
Not plus AND, right? NOT gate and AND gate. That's why it is called NAND. So here, two gates are combined together, right? Two gates are combined together. That's why it is combined. Clear? Look here. NOR gate. So now you can guess it. Tell me, what are the two gates combined here?
NOT gate, OR gate.
Yes, NOT gate, OR gate. Look, NOT gate also basic gate, OR gate also basic gate. So here also two basic gates are combined together. So now you can easily understand the reason why these two gates are named as combined or combination, because these are the results of combining two gates. Here we combine NOT gate and AND gate and got NAND gate. Here, NOT gate and OR gate are combined to get NOR gate. So these are not unique gates or special gates. These are the result of combination. So that's why it is combined. These three gates are known as basic gates. The reason also very simple. Have a look at them. When AND gate and NOT gate are combined, NAND produced. When OR gate and NOT gate are combined, NOR produce. So we can simply say that to build or to manufacture combined gates, these gates are must, right? These AND gate, OR gate, NOT gate are the basic gates, so are the foundation for building these two gates. If you don't have AND gate, or if you don't have OR gate or NOT gate, you cannot build these two gates. So since these are the fundamental gates for the production of these two gates, these are called basic. Very simple English meaning, right? Basic gates, because these are important for produce the others. Clear? So that's the reason why we have these two basic logic gates. We have three gates: AND gate, OR gate, NOT gate. And we have two more combined gates: NAND gate, NOR gate. So this is NOT plus AND. Even I can put that NOT plus AND. I put the plus in order to show the combination, right? NOT plus AND, both are combined. Here it is NOT plus O, right? NOT plus O. But fortunately, we will be working with only basic logic gates. Only basic logic gates included in our syllabus, not the combined gates, because combined gate becomes little complex because there are two gates are joined together. So you will learn such things in grade 10, but not here. So we will learn only the basic gates, only about AND gate, OR gate, and NOT gate. Okay, but I wanted to show the other type also, because when you learn something newly, you should understand the basics, right? So if I mention only this AND or NOT, then you may get some wrong idea. You may get the wrong concept. You may think that you have only three gates. Now you realize there are many gates available. Some of them are categorized as basic, and the rest of them are categorized as combined. You also know the reason. Okay. So better we can write it after that. I have to explain AND, then NOR, then NOT. Okay. So heading: types of logic gates. Types of logic gates. Types of logic gates. Right. So now divide your heading into two, as I have divided here. Divide your heading into two. Okay. So this is the heading: types of logic gates. Divide into two and show the examples and everything. Show this, copy this down. Use block letters, capital letters. All the names must be capital, right? Including NAND and NOR. show these two things within the bracket, because then only you can easily remember that the gates involved in these two. Here, not an and, these are involved. Here, not or. Finished?
Yes, sir.
What about the others? Have you finished?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, you all finished, right? Okay. So hereafter, you will focus on basic logic gates, not the combined gates, right? We don't have combined gates in our syllabus. But if you can remember the names, right? You have Nand and no. So now heading basic logic gates. Basic logic gates. Basic logic gates. Right. So first of all, write something, because I already explained, write something. These gates are the reasons, these gates are the reasons, REASONS, reasons for building, 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 for building combination of logic gates, combination of logic gates. I repeat the sentence again. These logic gates are the reasons for building the combination of logic gates. Right, next point. Next point. When two basic gates, when two TWO, two basic gates are combined, when two basic gates are combined, comma, put a comma, combination of gates are formed, 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 which means built, formed, FORMED, formed. Have you understood? When two basic gates are combined, combination of logic gates are formed. Okay. Next point, third point. And capital AND, and capital AND, comma O, capital OR, O, comma not, NOT, capital, not, are the basic logic gates, are the basic logic gates, are the basic logic gates. Okay, so now heading and logic gate, or even you can write and, that's enough, and, capital AND, and. Okay, look 1 second. You need to study about 3 logic gates. Now you only know that logic gate is an electronic circuit that needs electricity and will perform a specific function. As a result of the function, an output is produced. These are the things that you know only, right? Up to now, you only know these things. Hereafter, you will be learning some other things. That's why I'm recalling. Right, look here. You have to study about 3 gates. Look, you need to know 3 things about a gate. So which means I will be introducing 3 points, 3 things about every gate. For example, for AND gate, I have to introduce 3 things. The same 3 things will be introduced for gate 2. There may be so for example, okay, take a look at the first point. For every gate, there is a symbol used in electronic, right? For AND gate, there's a symbol used. Earlier, I have put a rectangle. Actually, that is not the symbol. That's why it is called block diagram. That is an overview. But in electronics, every gate has a symbol. So when I explain about AND gate, I have to introduce the symbol. Even when talking about OR gate, the symbol has to be introduced. For NOT gate also, it must be. Right? So symbol is there, but every gate has a different symbol. That's the first point. The second point to be introduced about gate is the function, right? The function, sometimes we call it as logic, right? Logic, which means the function of the gate. So for AND gate, we have to introduce the function. We have to discuss. Even for OR gate also, there should be a function. But if you think about the function of AND gate and OR gate, then you can clearly see a difference. They are not same. Even for NOT gate, there will be another function. So we have to introduce. So first one symbol, second one function. These are enough for me, for you, maybe for grade 8 students, these are enough. These 2 points are enough. But it would be better to introduce the third point that may be very useful for, following your next years, maybe grade 10 or something. That is building a simple electric circuit for every logic gate. Right? For AND gate, there is a function, right? In order to understand the function, we can build a small electric circuit using battery, switches, and bulb and understand. Because sometimes the function is confusing. You may have some problems in understanding. But when a small electric circuit or simple electric circuit is built, you can easily understand. That may be the reason why we have to introduce or we have to form a simple electric circuit for AND gate, OR gate, not gate. But even though they are simple electric circuits, they are not same. So these are the 3 things to be introduced for every gate. So don't think that it is burden or it is tough. It's very simple because we have to learn only 3 things about these 3 gates. Same thing, but they differ from gate to gate. Same points, right? Symbol, right? A function, that electric circuit, right? So I will introduce the AND gate, maybe symbol and other things later. Maybe in the next class we can cover only 1 gate or 2 gates because we have to go slowly. Then only you can understand because it's a new concept. Everything will be new, so we must go slowly by studying everything clearly, right? So maybe in the next class I will explain about AND gate. Sometime OR gate can be started, but it is difficult to complete at that particular time. So OR AND gate can be covered, right? Can be finished, but we can start the OR gate, but not finish because it takes time. Okay. So today we have only an introduction for logic gate. So I hope you have some idea about logic gate, right? Even though you cannot understand, you cannot get the 100% of logic gate, but at least something will be in your mind now. Okay. Right. So any questions asked? No, right? Does anybody have any other questions? Okay. So since no questions asked, please send your names now. Okay, so that's it for today. We can continue this and gates and other gates in the next class. Okay, thank you.